Let's begin section 10.1 on compound interest. Compound interest, we're going to calculate interest multiple times, but we still have just one deposit in the account. So a one-time deposit of money, and then interest is calculated on a regular basis. Sometimes that interest is calculated annually, which is one time each year. Sometimes semi-annually, which would be 2 times each year. Quarterly, like 4 quarters in $1, would be 4 times each year. And monthly would be each month or 12 times each year. Let's get started. In question 1, you borrow $12,500 at 8% interest, and you're going to see that word compounded. And they're going to tell you how you're compounding your interest. In this case, quarterly. So quarterly means 4 times a year. Okay? And then your account is going to be good for 6 years. Find the interest rate per compounding period. We call that the I, and in our formula, that's going to be right here inside of the parentheses. To calculate the I, we're going to take the interest rate per year, so percentage rate per year, in the numerator, and in that case, for number 1, it is 8%. In the denominator, it's number of times you're going to compound for just 1 year. So the number of times to compound interest for only 1 year. So in 1 year, if we compound quarterly, I'm just going to write the word quarterly to remind us that's where we're getting that. Quarterly means 4 times a year. And 8% divided by 4 would be 2%. When we get to this table, we're going to be looking down the 2% column. Find the total number of compounding periods. This really means how many times are they going to calculate interest for the entire account of your loan. Well, they're compounding interest quarterly. That means 4 times a year, times the number of years. Well, in this case, our account is good for 6 years. So 4 times a year for 6 years is a total of 24 times to calculate interest. That means in our chart, we're going to look at row 24. Let me highlight both of those. Here's row 24. And going down the 2% column, we find where they intersect. Where they intersect is this number right here, 1.60844. Part C then says, find the compound amount. The compound amount is the total amount in the account. This is really the principal and the interest together. That's why you're seeing this number over a 1. That 1 is really representing the 100%. Okay? So we're going to take the amount that they borrowed or invested, depending on whether it's a loan or a bank account, the $12,500 times the number in the table. So the $12,500. And to find the number in the table, we used what we found in Part A and Part B to find the row 24 for the number of times to compound over the whole 6 years of the loan, and also the 2% for the compounding period, and that was 1.60844. And when we multiply those together, I get a value of $20,105.50. Part D says find the compound interest. This is interest only. And the interest is the amount above and beyond the principal that was invested. Well, if $12,500 was invested, but the bank account totals $20,000, It's the difference in those. It's the amount above the $12,500 that was invested. So we're going to be subtracting the total amount minus the principal. In this case, the total amount was $20,105.50, and the principal was the $12,500 that was initially invested. After that subtraction, I have $7,605.50, and this is our interest only. Let's go ahead and give question 2 a try. Okay, I have our annually, semi-annually also listed here. Okay, we're going to deposit $2,000 in an account that earns 3% compounded semi-annually. Semi-annually means we're going to have 2 times a year to calculate that interest. And our account's going to be good for 5 years. Find the compound amount and find the compound interest. On this one, we don't have all of those different parts separated for us to find what column we need to be in and what row, but that's where we want to start. We want to calculate the I and the N. The I helped us find the column. That was our percentage rate divided by the number of times you compound in a year. So in this case, we have a 3% rate, and we're going to compound semi-annually. Again, I'm going to write semi-annually so you know where I'm getting the 2. And 3% divided by 2 is 1.5%. That's going to tell us what column to look at. Our N says that we're going to calculate interest semi-annually times 5 years, or 2 times a year for 5 years, or 10 times total. And that's what row we're going to look at. Let me go back to our chart, and I'm going to look at the 1.5% for the column and row 10. I'm going to use a different color highlighter here. This time we're looking at 1.5% for the column, and we're also looking at the row that was 10 times, and where those intersect, oops, excuse me, get my ink, is 1.16054. So the number from the table is 1.16054. And that's what we're going to use to multiply by our deposit. So to find the amount in the account, we're going to take our $2,000 deposit times that number from the table, 1.16054. So the amount in the account is $2,321.08. You could think of that like the maturity value of the account. Part B, the interest only. Again, the interest only is the amount above what was deposited. If $2,000 was deposited, we're going to take the total amount and subtract away the $2,000 that was deposited, and we get $321.08 is the interest only. Let's try another example. Find the compounded amount, think maturity value or total amount in the account, and the interest earned. $5,000 was deposited for 4 years at 9% compounded monthly. To find the I column, we're going to take our 9% and divide by the number of times we compound in a year, which is monthly, So 9% divided by 12 is 0.75%. Or as a fraction, that would be 3/4%. The N for the row is going to be the number of times you compound in a year, which in this case is 12, times the number of years, 4 years. So there will be 48 times that interest is calculated for this account. Let's go back to that table and find the 3/4% column and also the row 48. Going back, I don't see a 3/4% column. I see a 1/2 and I see a 1, and also our chart ends at 30. So what we're going to do when that happens is we're going to use the original formula. M equals P, parenthesis 1 plus I to the n power. And we're going to sub in what we know. Our P for principal was the $5,000 that was invested. 1 plus the I was the 3/4% or 0.75%. Here we're going to need to write that as a decimal. Let me write 0.75% for now. And then the exponent was our N for 48 times. In our formula, we need to convert this to a decimal. 5,000 times 1 plus 0.75% is going to be pretty small when we move our decimal backwards 2 spots. Keep in mind that when we were using that chart, it actually made all of these calculations for us, which is what made those first questions so quick. Following order of operations, I'm going to add inside the parentheses first, and now I'm going to use my calculator to calculate 1.0075 to the 48th power. I'm going to write down all the decimals that my calculator gives me. 1.4314053333. Now I'm going to multiply by 5,000, and I get 7,157, 7,157, and I'm getting to an answer, so I'm going to round here at 3 cents. This is the amount in the account. To find just the interest, so we needed to find the compound amount, did that. To find the interest, we're going to compare the amount in the account and how much was deposited. And the amount above and beyond what was deposited is the interest. So keep in mind as we finish section 10.1, this number right here is what we would have found in the table. So the table was actually calculating this addition and exponent for us to make the earlier questions 1 and 2 a little shorter amount of work. But we could have done the calculation ourselves if we chose. That's the end of 10.1.